So question 4 is going to ask us to create a function called 3func. We're going to take one input scalar value x and we're going to assign it to an output y based on the following. If it's from 0 to 10, we're going to use sine of x, so y equals sine of x. If it's from 10 to 20, we're going to use y equals cosine of x, and if it's 20 to 30, we're going to use 3x minus 7. And we only want 3 logical comparisons in the function, and then we're also going to know that it has to be from 0 to 30. So if we check our intervals, we have x is less than 10 and greater than or equal to 0. We got x is less than or equal to 20, and we got greater than or equal to 10. We have x is less than or equal to 30 and greater than 20. So these are actually 6 logical comparisons that we don't want. So that's 6 right here. Each one of those is a logical comparison by itself, and we only want 3. So let's start taking off whichever we don't need. So we already know it's going to be in between 0 to 30, and so if we say x is greater than or equal to 0, that's unnecessary because it's already assumed. And if we say it's less than or equal to 30, it's also unnecessary because it's already assumed. So these are our 4 that are left, and now we're going to have to start taking off. So for interval number 1, we know it's from 0 to 10. So by saying x is less than 10, and it's already assumed it's greater than or equal to 0, that's just number 1. For number 2, for interval number 2, we have x is less than or equal to 20 and greater than or equal to 10. We can actually take this logical comparison out, because if we say x is less than 10 at interval 1, that means the only other option x has is to be greater than or equal to, and in this case is both greater than and equal to 10 in the second interval. So this is actually redundant, because when you say this right here, less than, you're already implying the opposite exists in the second interval, which is greater than or equal to. So that's unnecessary. And we say x is less than or equal to 20, that's actually necessary, because that's the endpoint for our interval. And then in our third interval, it says x is less than or equal to 30 or greater than 20. Well, by saying that x is less than or equal to 20, you're already implying that the third interval has to be greater than 20. So this actually is unnecessary, because it's implied through this statement right here. So we actually got ourselves to do only 2 logical comparisons instead of 3, which is better than just having 3. The less the better. So if we were to write this out, we have our function, and our output is y, and that equals to 3func of our input x. And then we're going to have to start off with our if statement. So if, and our first interval, which is x is less than 10, we're going to assign it to y equals sine of x. Else if, that's going to be our second condition. So if we don't want to just do else, we do else if, and that allows us to write a second condition. X is less than or equal to 20. We're going to do y equals cosine of x. And then else, that's our final condition, which is x is less than or equal to 30, which is implied, and greater than 20, which was also implied because of this statement right here. We can't write any condition when we say else. So we say just y equals 3x minus 7. And we just end the if statement and end the function. So this will end that, this will end this. And that is how you're going to write number 4. So let's check our work in just a second. Want to make sure that our function works. Let's test it out. So we have our first interval, our second interval, and our third, which is implied right here, 20 to 30. We got our 3 outputs, possible outputs. So if you do 3func of 0, it should be in the first interval, which is sine of x, and sine of 0 should be 0. That's what we get. If we do 3func of 30, that should be in our final interval, which is 3 times 30 minus 7. That gives us 83, and that is what we get. And if we do 3func of 4 pi, so 3func times 4 times pi, that should be in our third interval. And look what we got. We got 1, and that's correct because cosine of 4 pi is 1. So that makes sure that our interval works.